Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is binary tree maximum path sum. So let's read the problem statement. It's a very popular question. But as you can see the likes, and it's a hard type problem. So let's read the problem statement and try to understand the problem. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence and an edge connecting them. So this is one of the example of the path. So nodes are connected with an edge. A node can appear only at most once. Okay, so every node can appear only at most once in the path. We have to find the maximum path sum of a non-empty path. So what is the path sum? Sum of the nodes of the values in the path. So if I say this path, the path sum will be 2 plus 1 plus 3, that is 6. So let's see this example in the dashboard and understand again what is can be the paths here. So this can be one of the path. 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 Right? So it's not necessary that the path should go from the root. So the maximum path sum is the summation of the node values in a particular path. So if we see this path represented by black, the path sim will be 15 plus 20 plus 7, that is 42. So let's erase this. Now how we will find the maximum path sum? We will traverse the tree. We will do tree traversal using DFS Postorder. Why Postorder? Because I want to calculate the maximum at each node by first going to the child of that parent. So it will be left, right, and then root. Okay, so once again, if the post order will be, because we have to find the maximum from the left and the right, and then add into the root values, root dot value, to find the maximum path sum. So we have to first complete the left and the child first. So let's start from the root node. So we'll traverse in the post order, like we'll go left, then we'll go left. So it's null, so we'll return 0. Right? So if it's null, we'll return 0. We have completed left, then we'll go right, then when it's null, we'll return 0. Now here at this point we will do two things. First, we will take a global max that will represent the maximum path sum, and we'll initialize it with int max. Sorry, int min. We'll initialize global max with int min. Now when we reach 9, during backtrack we return 0 and 0. Now at 9 we have to do two important things. First we have to update this global max. So we will calculate the sum of the values of the left child and right child plus the parent of this subtree. So it will be 9 plus 0 plus 0, that will be 9. Is it greater than the max in min? Yes. So we'll update max equal to 9, and from 9 we'll return the maximum of left plus root or right plus root. So as left and right both are 0, we'll return 9. So from 10 minus 10 we have completed left, we'll go right, then again left, then here we go null, we'll reach null here on the left and right. So we'll return 0 and also from right 0, and now at root 0 again we'll calculate the max. So max will be 15 plus 0 plus 0, that will be 15. It's greater than 9, so now it will be our max, and we'll remove 9. We'll update 9 with 15. Now we'll return from 15 the left plus the left value plus the root value, or the right value plus the root value. So it will be 15 because it has no root and right, both are 0. From the 20 we'll go on the right side, we'll traverse right. On the right we again have 7, which is null and null again, so it will be 0, it will be 0, and again we'll be returning 7. And before returning 7 we'll again update the max. We'll see if we have to update the max. So as 7 is less than 15, so no need, still max will be 15. So here we reach 20, again we'll calculate the max. So max will be 15 plus 7 plus 20, that will be 42. Now is this greater than the max already stored? Yes. So we'll update max equal to 42, and now from 20 we'll return the 20 plus the left value or 20 plus the right value. So it will be returned 20 plus 15, that is 35. Now at minus 10 again we'll calculate the max. So max will be 9 minus 10 plus 35, it will be that is 34. So it's still less than 42, we'll not update the max. So max will be still 42 from this path. And finally we'll return the maximum of minus 10 plus 9 or minus 10 plus 25, that is 25. So we have our max value, that is this one, 42, from this path. So I hope this explanation is clear. So let's see the time complexity for this algorithm. So as we are doing post order, so the time complexity for post order is order of n, because we traverse each node once, and this will be time complexity. The space complexity is also order of n, because the max as the for the DFS implicit stack is maintained, so the maximum elements in the stack can be all the elements, that is n, can be in the stack. If the worst case is that the tree can be a skew tree. So space complexity and time complexity is order of n. So let's jump onto the code part. So if you see we have initialized our sum as a global path sum as an int min dot value, and we are doing max, we are calling maxsum with the root that we received in the main method. And in the maxsum we have our base condition, if the root is equal to null we'll return 0. We are doing the post order traversal, first iterating the left root and the right root, and then when we reach the parent again while backtracking, we are adding the left plus right, whatever the left value is, whatever the right value, and with the root dot value, and we are checking if it is greater than sum, we are updating the sum with this value. Now when we are returning from the node, we are returning the max of L plus root dot val or R plus root dot val, as explained in the example. Now here is one more thing that we are doing, that is max dot math dot max, because it can be the case that the left part can return -1 as well, negative as well. So suppose this is negative, so we don't want the path sum to include this negative, because it will decrease the path sum only, right? If left is negative or right is negative, any of the child is negative, then we don't need that negative value because it will only decrease, and we want the maximum path sum. So that's why we'll compare it with 0 and take the if it is negative, we'll take the 0 for that left part or the right part. So let's try to run this program. So yeah, it's running fine as the test cases are accepted. So I hope you like this video, and if you like this video, please share and subscribe my channel. It will give me motivation to present more such videos in front of you guys. Thanks for supporting. Bye.